Okay, so I'm going to 5. This one is like integration 1 to say 4, and you have natural log of x over x to the 6 dx type. Okay, so if you have like that, I will do like this format here. So derivative integral. So my logarithmic function always will be in a derivative form. So then take here natural log of x, and then 1 over x to the 6, meaning is x to the negative 6, right? So that will go here with dx. Now derivative of natural log of x is 1 over x, and integral of this one will be negative 5 over x to the negative 5 over negative 5. Is that right? You add 1, and then you don't go further, you stop. So we'll go this way and we'll come this way. This is the plus and this is the minus. So then my integral is now coming out like negative 1/5 x to the negative 5 natural log of x minus integral, I'll put the limit at the end, will be plus now when you multiply like this. So then you get x to the negative 6 over 5 dx. Do you agree with that? Because I'm multiplying 1 over x with this, so x goes up with a negative 1 exponent, so that's why x to the negative 6, and negative 5 with a negative sign makes it positive here. So then finally you get negative 1 over 5 x to the negative 5 natural log of x plus 1 over 5. The integral of this one will be again x to the negative 5 over negative 5, and then our limit is 1 to 4. Next you just need to plug the limit. So when you plug the limit, I think you can do it in the calculator. Should I leave it here so that you can try? Yeah. Okay, so I'm leaving here. So what you do, you can just take a graphing calculator, type this function in the graphing calculator, or you simplify it first and then put it. So it is like negative natural log of x over 5x to the 5 minus 1 over 25 x to the 5, and then limit 1 to 4. Just plug the limit afterwards. All right, so you can do this. Okay, so I'm taking more examples. Let me try another one. First, make the substitution. So what is our substitution? Definitely starting from here, because here is the difficulty. So you say u equals x squared, then du equals 2x dx, and let us put it here. So 1/2 du is x dx. Now we want to split our problem just to see that if I write x squared cosine x squared x dx, is that okay? Because you see I got x dx, so I need to isolate that one. So from x to the 3 I take 1x, and now everything looks nice. X squared is u, so you have u here, and then you have cosine u here, and x dx is 1/2 du. Now it is nice. Nice meaning is I can use now the shortcut one, or integration by parts. So you write here u cosine u. So the derivative of u is 1, and then it is 0. Cosine u will give me sine u, and then it will give me negative cosine u. Sine u and sine gives me negative cosine u. Now I follow like this, plus minus like this. Since it is 0, I don't have to go this way because it's 0 already, so you can ignore that term. So then you get 1/2. Now you get u sine u minus will be plus, and you get cosine u. And then substitute back what is your u. U is x squared. So you get x squared sine x squared plus cosine x squared. And we are done. Plus integral constant. Yeah, so that's so simple now. So you just need to see how to make the substitutions and form integration by parts. G1, it is given like this. G1 is -2, and then you have G5 is G5 is 1. Integral 1 through 5 gx dx equals -5. You need to evaluate this. Evaluate integration 1 through 5 x g prime x dx. Yeah, that one you need to do. So then you see that I have a derivative function here, and my results are given in terms of original function. So then what we do, I will use the shortcut one. So I have two functions. X is here for derivative, and for the integral I'll take g prime x. Now the derivative of x is 1 and then 0. Who can tell me what is the integral of g prime x? Anyone?
G of x.
Very good, thank you. G of x. What is the integral of g of x? Definitely integral sign. Gx dx, see that? Isn't it? So the next integral. So now I have a plus sign, I have a minus sign. So then avoid the limit first. First take the integral. G prime x dx. We know that this one is, we need to multiply like this. So it is x gx, like this first. Then this. Then you have a minus integral gx dx. Is that right? That's it. So then when I say it is 1 to 5 is my limit, like x g prime x dx, so that means I have to take here x gx minus integral gx dx, and my limit 1 through 5. So that means you have x gx, your limit is 1 through 5, minus this goes integral on these, so 1 through 5 gx dx. Yeah. So now what happens finally? Finally we see now this one is, when I put 5 on these, I get 5 g5 minus 1 g1. So I'm done for the first part. Minus integral 1 through 5 gx dx is already here, which is -5. So I plug all the values I have. 5, my g5 is 1, my g1 is -2, is 12. Yeah.